Hello everybody. Let's start our students' independent work with a teacher. Today's topic is data analysis and processing.
Data analytics, or DA, is the science of examining raw data with the purpose of drawing conclusions about the information. Data analytics is used in many industries to allow companies and organizations to make better business decisions, and in the sciences to verify and disprove existing models or theories. Data analytics is distinguished from data mining by the scope, purpose, and focus of data analysis. Data miners sort through huge data sets using sophisticated software to identify undiscovered patterns and establish hidden relationships. Data analytics focuses on inference, the process of deriving conclusions based solely on what is already known by the researchers. Now let's see a small video about data science.
Today, businesses face a diverse set of operational challenges. How do you know you're operating at maximum efficiency? Do you understand your risk profile? Are you minimizing exposure to accidents and disruptions? How can you be sure you're doing enough? The answer to those questions may lie within the data you already collect. Historically, the methods developed for modeling risk and reliability issues had to be simplified, limited by computing power and the types and amount of data available for analysis. Today, traditional methods that use engineering models, actuarial science, and statistics are being enhanced with data science. But what exactly is data science? Simply put, data science uses methods, processes, and systems to extract knowledge and insights from structured and unstructured data sets. Companies are collecting more data than ever before, and we now have the ability to gather, integrate, and analyze the data far more efficiently and effectively. Our new tools allow us to perform analytics that uncover meaningful insights. Artificial intelligence tools, such as image recognition and natural language processing, give us access to more varied types of data. Machine learning delivers faster and better predictions. And by using data visualization tools, we can quickly and easily connect the dots. These tools are helping us reveal insights far beyond the data's original intended purposes, leading to a shift in thinking from, do I have the right data to answer the question, to what questions can I answer with the data I collect? Ultimately, leveraging these tools allows us to more efficiently and effectively assess the risk and reliability issues that are most important to your business, giving you confidence in managing your toughest operational challenges.
The science of generally divided into, first, exploratory data analysis, EDA, where new features in the data are discovered. Second, confirmatory data analysis, CDA, where existing hypotheses are proven true or false. Qualitative data analysis, QDA, is used in the social science to draw conclusions from non-numerical data like words, photographs, or video. The term analytics has been used for many business intelligence software vendors, BI, as a buzzword to describe quite different functions. Data analytics is used to describe everything from online analytical processing, OLAP, to CRM analytics in call centers. Here is a huge amount of data available in the information industry. This data is of no use until it's converted into useful information. It's necessary to analyze this huge amount of data and extract useful information from it. Let's see the next video about data science, big data, and data analytics. Extraction of information is not the only process we need to perform. Data mining also involves other processes such as data cleaning, data integration, data transformation, data mining, pattern evaluation, and data presentation. Once all these processes are over, we would be able to use this information in many applications, such as fraud detection, production control, etc. Data mining is defined as extracting information from huge sets of data. In other words, we can say that data mining is the procedure of mining knowledge from data. The information of knowledge extracted so can be used for any of the following applications: market analysis, fraud detection, customer retention, production control, and science exploration. On this slide you can see main data mining issues. They can be divided into three parts: mining methodology and user interaction, performance issues, and diverse data types issues. The first one is include mining different kinds of knowledge in databases, interactive mining of knowledge at multiple levels of abstraction, incorporation of background knowledge, data mining query languages and ad hoc data mining, presentation and visualization of data mining results, handling noisy or incomplete data, and pattern evaluation. The second group are efficiency and scalability of data mining algorithms, parallel, distributed, and incremental mining algorithms. And the last group, handling of relational and complex types of data and mining information from heterogeneous databases and global information systems. On this slide you can see the data mining architecture. The major components of any data mining system are data source, data warehouse server, data mining engine, pattern evaluation model, graphical user interface, and knowledge base. Each and every component of data mining system has its own role and importance in completing data mining efficiently. These different models need to interact correctly with each other in order to complete the complex process of data mining successfully. User interface is the model of data mining system that helps to communicate between users and the data mining system. User interface allows the following functionalities. Interact with the system by specifying a data mining query task. Providing information to help focus the search. Mining based on the intermediate data mining results. Browse database and data warehouse schemas or data structures. Evaluate mined patterns and visualize the patterns in different forms. The next part is pattern evaluation models. The pattern evaluation model is mainly responsible for the measure of interestingness of the pattern but using a threshold value. It interacts with the data mining engine to focus the search towards interesting patterns. Data mining engine is very essential to the data mining system. It consists of a set of functional models that perform the following functions: characterization, association and correlation analysis, classification, prediction, cluster analysis, outlier analysis, and evaluation analysis. The next part is knowledge base. This is the domain knowledge. This knowledge is used to guide a search or evaluate the interestingness of the resulting patterns. Some people treat data mining same as knowledge discovery, while others view data mining as an essential step in the process of knowledge discovery. Here is the list of steps involved in the knowledge discovery process: data cleaning, data integration, data selection, data transformation, data mining, pattern evaluation, and knowledge presentation. Data integration is a data preprocessing technique that merges the data from multiple heterogeneous data sources into a coherent data store. Data integration may involve inconsistent data and therefore needs data cleaning. Data cleaning is a technique that is applied to remove the noisy data and correct the inconsistencies in data. Data cleaning involves transformations to correct the wrong data. Data cleaning is performed as a data preprocessing step while preparing the data for a data warehouse. Data selection is the process where data relevant to the analysis task are retrieved from the database. Sometimes data transformation and consolidation are performed before the data selection process. Cluster refers to a group of similar kind of objects. Cluster analysis refers to forming group of objects that are very similar to each other, but are highly different from the objects in other clusters. Data transformation. In this step, data is transformed or consolidated into forms appropriate for mining by performing summary or aggregation functions. Data mining. In this step, intelligent methods are applied in order to extract data patterns. There are two forms of data analysis that can be used for extracting models describing important classes or to predict future data trends: classification and prediction. Classification models predict categorical class labels, and prediction models predict continuous values functions. For example, we can build a classification model to categorize bank loan applications as either safe or risky, or a prediction model to predict the expenditures in dollars of potential customers on computer equipment given their income and occupation. Following are the examples of cases where the data analysis task is classification. First, A bank loan officer wants to analyze the data in order to know which customer, loan applicant, are risky or which are safe. Second, a marketing manager at a company needs to analyze a customer with a given profile who will buy a new computer. In both of the above examples, a model or classifier is constructed to predict the categorical labels. These labels are risky or safe for loan application data and yes or no for marketing data. Following are the examples of cases where the data analysis task is prediction. Suppose the marketing manager needs to predict how much a given customer will spend during a sale at his company. In this example, we are bothered to predict in numeric value. Therefore, the data analysis task is an example of numeric prediction. In this case, a model or a predictor will be constructed that predicts a continuous valued function or ordered value. With the help of the bank loan application that we have discussed above, let us understand the working of classification. The data classification process includes two steps. First, building the classifier or model. Second, using classifier for classification. Building the classifier or model. This step is the learning step or the learning phase. In this step, the classification algorithms build the classifier. The classifier is built from the training set made up of database tuples and their associated class labels. Each tuple that constitutes the training set is referred to as a category or class. These tuples can also be referred to as sample object or data points. Second, using classifier for classification. In this step, the classifier is used for classification. Here, the test data is used to estimate the accuracy of classification rules. The classification rules can be applied to the new data tuples if the accuracy is considered acceptable. The major issue is preparing the data for classification and prediction. Preparing the data involves the following activities. First, data cleaning. Data cleaning involves removing the noise and treatment of missing values. The noise is removed by applying smoothing techniques, and the problem of missing values is solved by replacing a missing value with most commonly occurring value for that attribute. Relevance analysis. Database may also have the irrelevant attributes. Correlation analysis is used to know whether any two given attributes are related. The data can be transformed by any of the following methods. Normalization. The data is transformed using normalization. Normalization involves scaling all values for given attribute in order to make them fall with a small specified range. Normalization is used when in the learning step the neural networks or the methods involving measurements are used. Generalization. The data can also be transformed by generalizing it to the higher concept. For this purpose, we can use the concept hierarchies. Here is the criteria for comparing the methods of classification and prediction. First, accuracy. Accuracy of classifier refers to the ability of classifier. It predicts the class label correctly, and the accuracy of the predictor refers to how well a given predictor can get the value of predicted attribute for a new data. Second, speed. This refers to the computational cost in generating and using the classifier or predictor. Third, Robustness. It refers to the ability of classifier or predictor to make correct predictions from given noisy data. Next one, scalability. Scalability refers to the ability to construct the classifier or predictor efficiently, given large amount of data. Interpretability. It refers to what extent the classifier or predictor understands. A decision tree is a structure that includes a root node, branches, and leaf node. Each internal node denotes a test on attribute. Each branch denotes the outcome of test. Each leaf node holds a class label. The topmost node in the tree is the root node. The following decision tree is for the concept by computer that indicates whether a customer at a company is likely to buy a computer or not. Each internal node represents a test on an attribute. Each leaf node represents a class. The benefits of having a decision tree are as follows. It doesn't require any domain knowledge. It's easy to comprehend. The learning and classification steps of a decision tree are simple and fast. Pre-pruning is performed in order to remove anomalies in the training data due to noise or outliers. The prune trees are smaller and less complex. Here's the tree-pruning approach listed below. Pre-pruning. The tree is pruned by halting its construction early. Post-pruning. This approach removes a subtree from a fully grown tree. The cost complexity is measured by the following two parameters. First, number of leaves in the tree. Second, error rate of the tree.
So, the lesson is over. Thank you for your attention. Goodbye.